So welcome to my lecture series. So now we discuss about applications of superconductors. So the superconductors, magnetically levitated vehicles are called maglev vehicles. So in Japan, superconducting magnets have been used levitate an experimental train above its rails and drive at a generator speed of 500 km/h. So with a minimal expenditure of energy, a smaller magnetic propulsion system may be used to launch satellites into the orbit directly from the Earth without the use of rockets. So the diamagnetic property of a superconductor is the basis of magnetic levitation. A sheet of superconductors in the superconducting state is kept below the horizontal bar magnet suspended from flexible chain and then lowered over the superconductor. As the magnet approaches the superconductors, the magnetic field due to the approaching magnet induced current in the surface of the superconductor. Since the resistance of the superconductor is zero, so the current persists in the superconductor and magnetic field due to this induced current repels that Bohr magnet. So when superconductors levitates the magnet, a magnetic mirror image formed in the superconductor such that there is always a north pole induced in the superconductor directly below the north pole of the levitating magnet, and south pole is induced in the superconducting directly below the south pole of the levitating magnet. So the mirror image moves with the magnet as the affecting its levitations. In fact, the magnet may continue to spin for quite a long time because its spin encounters no frictions other than the friction of air resistance. So when the surroundings of air pressure, so its result the levitation magnet is rise higher. So instead of a permanent magnet, the superconducting field is provided by the superconducting solenoid current. The repulsion between the superconducting magnet field and superconducting surface having a present current in the basis for magnetic levitation for trains and their machines. And the magnetic levitation train. And next one, Josephine effect. Josephine effect, two superconductors separated by the very thin strip of an Tesla form as Josephine junction. So the wave nature of moving particles make electrons to tunnel through the barrier. So as a consequence of tunneling of electrons, so across the insulator, there is a net current across the junction. So this is called as a DC Josephine effect. The current flows the even absence of a potential difference. And AC Josephine effect is that a DC voltage applied across the junction, two superconductors separated by the thin insulating layer cause RF current oscillations across the junction with a frequency omega equal to q by h cross. So further, if RF voltage applied along with the DC voltage, there is a flow of DC current across the junction. The Josephine devices, and is a current increase due to the tunneling effect. So therefore insulating materials like Josephine junctions capable of switching signals from the circuit to another with a switching time of 1 ps, and thus the Josephine junctions circuits are capable to strong information, since the Josephine junctions is a superconducting device so whose power consumption so extremely small, and size and weight are very small. So Josephine junctions computer has been fabricated within the volume of 1.25 into 10 to the power minus 4 meter cube, and cycle time of 2 ns, which is 10 times faster than the high speed superconductor based computers. So in that it is used to produce the microwave waves with a frequency And using Josephine effect, the value standard volt can be defined by the National Bureau of Standard with a very high accuracy. That's the 1 volt that is equal to 48, 35 and 93,420 megahertz. That from H by to E. Thank you. We are discussing next class.